Hey everyone, it's Mr. Boyd, your friendly math teacher, back at it again. And today we are going to be looking at ways of determining whether or not two triangles are congruent. In the previous video, we talked about what congruence was. It's when two shapes have the exact same angles and the exact same sides, or we could say all congruent angles and all congruent sides. But sometimes that's a little bit too much work. And so today we're basically looking at shortcuts. So rather than having to find all the angles and all of the sides of two triangles in order to compare them, we're going to have a shortcut. Now our first one is right here. That's side, side, side congruence. And so what all this is saying is if we have two triangles and three sides of one are congruent to three sides of the other, then they're congruent. So here's what that would look like. If the triangle shared the same markings, so those two sides match, these two sides maybe are a different length, but they're the same as each other. The corresponding sides are the same length, and then you got to have all three. Two is not enough. So we've got our third side over here. So if a pair of triangles is marked up in that way, we know that's side, side, side congruence. Okay, let's look at our next shortcut or our next theorem. Okay, this one is SAS, and that means side, angle, side. Now here's one of the important things to realize about this. Notice how this A right here, it's in between the two sides. So let's say I pick two sides. I have to now pick the angle that is in between both of them. And when I say in between, one way to think about it is like they're touching. So notice in here, this A, it's nice and close to this S, it's nice and close to that S. And when you draw in these two sides, you can actually see the angle that I'm talking about. So I draw those two on there. They are meeting right here. So now we have a side, another side, and the angle that's between them. So I can mark this one in the same way. That's what side, angle, side looks like. That also is enough information. If you know that information about two triangles, that's enough to say that they're congruent. And the reason for that is once you have these two sides placed in, there's only one way to connect them. And if this angle can't change, then this location and that location are set. There's only one place they could be, and there's only one segment that can connect them. Now onto our third one. This one, very similar, but it's just the inverted letters. So ASA, angle, side, angle. Again, notice the S is in the middle. So if I pick two angles, an angle here and maybe an angle there, then that means the side that is in between them. So in between those two places I wrote, that's this side right here. So now I have an angle that's in between two sides. Or you could notice this side is being touched by the angle markers in both angles, and it has to be that way. Okay, so I'm going to come in and I'm going to draw that on this one as well. So now they match. That's a pair of congruent triangles. And let's look at our last one. In our last set here, we have angle, angle, side. And again, the order matters. It's very similar to angle, side, angle, except in this one, the side is not in between them. So notice the difference. I'm actually going to mark the same angles so we can see the contrast. So I have an angle, and then I have a side which is not in between them. An angle, and a side that is not in between them. Now, I want to add one thing to that. When I say in between, that's called an included side. And same thing as when the angle is in between two sides. For side, angle, side, this is called an included angle. So sometimes we're going to hear about a side and or two angles and their included side, or two sides and their included angle. That's what we're talking about. So look for that on your assignment today. It's going to ask a question like, what sides include angle B? All that's saying is, if you had to write out the sides, which one of them would have the letter B in them? And then you'll be able to see, or which sides touch the spot where B is or the point where B is. Okay, so these are our four main postulates and theorems that we're going to be looking at today. And so I hope you've taken notes on this. If you need to go back and pause the video and draw these, or if you need to write down more notes, that would certainly be a good thing. Let's look at some examples of how to use them. For now, we're going to be asked questions like this one. And they're asking are the triangles congruent, but they're really asking a little bit more than that. We're also being asked how do we know? We need to justify our answer. So we can't just say, yeah, sure, they look the same. That's not what they want. They want to know, is this side, side, side? Is this side, angle, side? Is this angle, side, angle? Or is it angle, angle, side? And so let's dive into it with that in mind. Okay, first thing I notice, I've got some angles right here, and their included side is not labeled. And so right now, what I already have, it looks like I have an angle, and then I have a side. The side, notice, is not the side that's included between the angles. And so right away, I can see that that's angle, angle, side. Now we need to check the other triangle and make sure the corresponding parts are labeled in the exact same way. So here's what that's going to look like. I'm going to find angle B. Angle B seems to correspond with angle D. Okay, same marking. Good. Here's angle A. Angle A seems to correspond with E. And what about this side? Side AC seems to correspond to side AE. Okay, so yeah, sure enough, it does line up. So check. This is absolutely angle, angle, side. Now, you could dig into this a little bit more. So, for example, some people would say, well, wait a minute, isn't this angle the same as that one? And how would we know? Well, I hope you can remember that's called vertical angles. Okay, that's going to be really important vocab in this unit and for the rest of the year. Okay, and so now that we have that, we could take a different approach to this. We could say, that's actually angle, side, angle. Let's see over here. Angle, side, angle. So this would also be a correct reason. So how are we going to answer this? Well, we're going to answer it yes. And the reason, we could say angle, side, angle, or angle, angle, side. Now what I'm going to look for as your teacher, especially if you're saying angle, side, angle, I want to see that this is labeled on your picture, and I want you to write out that it's vertical. That's going to be really important for the stuff we're going to do soon. Okay, same question, different picture. Why don't you pause the video and see if you can answer this one. Here's what I noticed right away. Right here, I've got an angle, and I've got the two sides on either side of it. Same thing on this picture, angle and the two sides. So right away I can say, yep, because this is side, angle, side. That's one way to do it. Let's see if we can find another. Another way of looking at this would be if I said, hey, there's an angle, a side, and an angle. Are they marked the exact same way in the other triangle? Sure. One marker, right angle. I could also say angle, side, angle. Same question again this time. I would suggest that you pause the video, realize there are two questions. One of them's right here. Second one is right here. Pause the video, draw these in your notes, and try to answer the question for yourself. So that way, it's just like we'd have in class. You have a little bit more engagement. You're more likely to retain this stuff. Okay, so here they are. First one's going to be side, angle, side. How do I know that? Because I've got two sides right here, one side right there, and the angle that's between them. I have the exact same markings over here and the angle that's between them. What about the picture on the right? This one is maybe a little bit trickier. You have to realize this right here is labeling a side, and this right here is labeling a side. And I don't have any labeled angles. It looks like these two angles up here at the top might be congruent, but there's nothing in the picture that indicates that they are. We have no writing that indicates that they are. And so, truthfully, we really don't know. All I have here is two sides that are marked. And so I'd say, oh yeah, sure, side, side. But that wasn't one of our theorems. So that's not what we want. Are they congruent? I'm going to say not sure, because I don't know. Some textbooks will say no, but I don't really know that they're not congruent. They look like they are. I just don't know that they are, and so I can't make any claims at all. And so that's why I'm going to leave my answer as not sure for now. All right, let's talk about the reflexive property of congruence. The reflexive property of congruence is a really big name for saying that if you line two people up back to back and they are the same height, then you'll be able to see that. Or you could think about it like this. There are two triangles on the screen right now, and this segment AB is only in one of them. If I call this triangle 1 and triangle 2, that's clearly a side length of triangle 1. If I come down here and I label this, that is clearly part of triangle 2. And they're congruent, which is fine. That's nice. But what about this one that goes down the middle? Is that in triangle 1, or is that in triangle 2? Well, it's definitely in triangle 1, but it's also definitely in triangle 2. All the reflexive property says is that it is the same length in each triangle. And here's why that's useful. Because this little tick mark here and this little tick mark there say those two segments are congruent. These two marks here and these two marks there say that those are congruent. Now with this third side, I can say, hey, it's the same in both triangles. And here's why that's powerful. Look at what's labeled in the top triangle. One side, two side, three sides. What about the bottom triangle? One side, two side, three side. All three of them are labeled, and so this falls into the category of side, side, side. And I now can definitively say that these are congruent triangles. Okay, and we've got one more, and then we're going to cut it short for today. So this is just a theorem that's in our book, and all it says, if you have two angles of one triangle, two angles of one triangle are congruent to two angles of another, two angles of another, then automatically the third angles will also be congruent. Now let's take a minute and think about why that is. Let's say that this is an 80-degree angle, which means then this also is an 80-degree angle because they're corresponding. And what if this is 40? That means this would also have to be 40. Now, based on what we learned in our last unit, we can remember that a triangle has 180 degrees on the interior angles if you add them all up. And so, looking at this picture, what would angle F have to be? Well, they have to add up to 180, so that means it's 60. What about this one? What about angle C? They have to add up to 180, and so the math will tell us that has to be 60. And all I'm doing is 180 minus 80 minus 40 equals 60. It's the same exact math for either triangle. And so that's all the book is saying. If two angles match, then automatically the third angles are going to match too. That's what this math right here is saying. Okay, and so that's a little fact we can use anytime we see that. And what we can do then is we can add these little markers to our picture here. Now notice, I'm putting down 3 markers. The reason there was 2 markers instead of 1 is to show that the one with 1 mark is different from the one with 2. The one that has 3 is still a third different angle. Okay, I think that'll be enough for right now. In our next lesson, we're going to talk about how to write out full-blown proofs. But right now, let's make sure we're feeling really good about how to deal with these 4 theorems. That's all for now. I'll see you next time.